when we want to generate an ALP, that is write a assembly language program to generate or create a square wave. Suppose the pin required or on which we required the square wave is port 1 pin number 2, that is P1.2. Okay, so B2 is nothing but P1.2. So for that, if we prefer the first method or first structure, like you have to make high pin and then low pin, as this pin is used as output pin, so no need to declare output as it is earlier, or default it is an output pin. Okay, so this is the method one. So make high, give some delay, make low, give some delay. If you want to generate square wave, and that too duty cycle is same for on as well as off, so whatever delay is there, so same delay should be applied for second also, second state, that is high state delay remains same to the low state delay. So according to that we will generate. And another method is, if instead of using two separate instruction, that is set and clear with two delay functions, so if we go with this instruction, that is CPL complement P1.2, whatever the earlier status before this, it will be simply complemented, that is change the status high to low or low to high. So in this case you have to use only one delay instruction in main program. Delay function remains same. Use or execution is two times, one for one state, another for another state. But writing instruction is somewhat easier, or it will take a less number of instructions, so its code size is also automatically reduced. So as per the convenience and requirement, you have to choose the required instructions or appropriate instructions. But another part from this program is remains, that is 66.67% of the duty cycle. So see, when we discuss regarding this, okay, so now what will be our next step? If we want to generate an duty cycle, here I will add of 66.67 or 66, or instead of that you may say that the 2/3. If we consider 50%, then it is considered as a half part, as we have seen yesterday. Screen is visible to you or not?
Yes, sir, visible.
Okay, so on and off time remains same, so it considered as 50-50, and combine is 100% or 1.5.5. And if we consider the duty cycle of 66%, okay, so in this case, if we want to use the duty cycle as 66%, okay, I will reduce some extent duty cycle. In this case, if I mention or draw the picture of this, clear आहे का? हे बरोबर आहे का for this? Hello, cycle असेल. Okay, cycle 1, cycle 2, cycle 3, and continues. If we consider a duty cycle of 66%, and here on time is equal to off time, मग याला आपण 66% duty cycle म्हणू शकतोय का?
No, sir.
So for that purpose, we have to use see, if I consider this, just I'm try to draw the concept related to showing you. Okay, so in this way, if I am using one part, second part, and third part. So we will consider this is our cycle 1. You say simply for this. Again, you have to add one more time slot. And in that case, just try to understand what I am saying. Okay, so so here I should be make this border high, and then here this side. Okay, so it will looks like this. Sorry, here it should be only the bottom side. Now it comes. Now I will on the bottom side. Okay, so see, when we consider duty cycle other than 50%, and now we are considering more than 50%, that is 2/3. 2 by 3. 2 by 3 is nothing but 66%. Say 2 divided by 3. And let's correct it. See. Okay, so when we use 2 by 3, that is 2 part of complete total number of parts are 3. Out of that, 2 parts are on and 1 part is off. So in that case, we consider as 66.67 or 66% duty cycle. Okay, so this is the case for generation of 2/3 of duty cycle or 66% duty cycle. In this case, you have to make your pin high for 2 parts and 1 part remains off. So in this way, total 3 parts are dedicated, and out of that 2 parts are on and 1 part is off, so that we are able to generate 66.67 or simply 2/3. 2 parts on and 1 part is off. So for generation of this, when we are discussing %, on time and off time remains same. So when we give instruction for this, sorry, here instruction is suppose a call. Okay, so a call delay is similar here also, a call delay, and same delay is there. That's why we were return single function a call delay after setting, and after clearing also a call delay. So this is the case for generation of 50%. Okay, but now we want to generate a duty cycle of 66%. So in this case, what should be the modified instruction to generate the 66% or 2/3 of the on time and 1 part is off time? So now earlier we seen that a call for on and a call for off. Okay, or
सर वेटिंग रूम चेक करा.
लवकर जॉईन होत नाहीत काय? 40 झाले त्यांचं परत मेन 1. अजून कोण आहेत? पाटील. ओके, इज इट ओव्हर? इम्रान झाले एवढेच होते का?
हो सर.
जेवढे प्रेझेंट आहेत ते अटेंडन्स असे मार्क होते. मी इथं क्लिक केले की त्या इन्स्टंटला जेवढे आहेत तेवढे सगळे येत आहेत इथं आता दाखवतो. 14/7/2020 9:41 9:41. तर रॅन्डम कुठेतरी एखाद्या ठिकाणी क्लिक केलं की जेवढे नंबर असतील ते प्रेझेंट असतील. अदरवाइज
सर
यू
मी आता टाकलंय.
नाही नाही, you write in comment box, no problem, but some of the candidates are mentioning the number in comment box and they simply left the meeting. So it will look like whenever you are entering in the comment box, it will be considered as a present, and if you are not there, no problem, as per your thinking, not personally you, but some of you. But now I am telling you that whenever I want to take attendance, I will simply make, so this is your chat box and these are the participants. So when I click at the participant, it will scroll down. You might be seeing this, and after that I will simply click here. So it will generate that time attendance, whoever are the participants, like this. Earlier it was for 9:41, now 9:42. Okay, so whoever is there as a participant, if it is mentioned in chat box or not, no problem. Okay, so all these are mentioned here. Okay, it will be automatically generated, no problem. Okay, as some people are joining the lectures for attendance only, and after joining they will not listen anything or wandering here and there, I don't know. So randomly I will call anyone as yesterday or day before yesterday's practice. Okay, leave it. So we are discussing related to the 66%. Okay, so instead of this DELAY delay, okay, same condition is there. We'll see here, but इथं काय करावं लागेल बघा, इथं एक डिले दिला, इथे एक डिले दिला, इथं काय करावं लागेल आपल्याला, बरोबर आहे ना, ऑन साठी एक आणि ऑफ साठी एक डिले. इथल्या ऑन साठी काय करावं लागेल,
2 डिले.
2 डिले द्यावं लागतील. म्हणजे तुम्हाला काय करावं लागेल, इथे एक डिले द्यावा लागेल. ओके, म्हणजे 2 पार्ट डिलेचे असतील. वेन वी वॉन्ट ऑन टाइम हाय, दॅट इज सेट, 2 वेळा डिले द्यायचा आहे आणि मग ऑफ साठी एकदाच डिले द्यायचा आहे. म्हणजेच काय होईल, हे 1 + 1 2, हा 1 पार्ट, हा 1 पार्ट आणि हा 1 पार्ट, कॉम्बिनेशन काय बनणार याचं, 2 पार्ट्स. If we merge together, so 2, and this is again 1. So if we consider the duty cycle like this, 2/3, it is applicable. Total is 1 + 1 + 1 3. Out of that, on time is 2 and off time is 1. So T on
2/3.
2/3, T on divided by T on plus T on
0.666.
666, whatever. Okay, so in this case, what is to be modified? Modified instructions काय असतील इथं सांगा. काय चेंज केलंय फक्त आपण,
तर डिले
डिले.
डिले दोनदा द्यावा लागेल
फक्त
स्टार्टिंग इन्स्ट्रक्शन.
ऑन साठी आणि ऑफ साठी, दोन्ही साठी का फक्त ऑन साठी?
ऑन साठी सर,
साठी सर.
फक्त ऑन साठी. If we'll insert the instruction of delay like this, okay, so it is sufficient to generate an delay. This I will. Okay, see, is it visible? So if we are considering 66%, in that case, as it is org, either you go with 0, sorry, 0, okay, 00h. So set bit, add delay 2 times, whatever delay. Now we are not discussing how much delay, 1 second, 1 millisecond, 10 millisecond, just considering that some delay, general delay. Okay, so call delay 2 times, and after that clear the bit, whatever bit is selected, and after that we will add delay, 1 time delay. So in this way, 2 part will be on and 1 part remains off. So combined effect is 2/3. So 66.67 or 66, whatever. And in this way, the process continues to generate the wave, not we directly say that the square wave, as its on time is more and off time is less. So we consider rectangular wave. Okay. So waveform having the duty cycle of this 66. Okay, and this function remains same. So is it possible to generate the duty cycle of 66% in by using second method for this? Just think on it. Any possible आहे का? We have seen for 50%.
नो सर.
Why?
सर कारण आपण कॉम्प्लिमेंट केल्यावर ते कॉलला आल्यावर आणि सर डबल होईल ना
म्हणजे
सर. 0 असेल आणि 0 आपण कॉम्प्लिमेंट करून कॉल डिले घेतलो आणि आणखी एकदा कॉल डिले घेणार आपण.
जर मी असं केलं ओके तर काय होऊ शकते?
0 म्हणजे आपली ऑन पिरियडला डबल डिले मिळाला ते ठीक आहे, पण आणि आपण आणखी एकदा कॉम्प्लिमेंट करून आणि 0 म्हणजे
बोला जे असेल ते बोला.
ऑफ असेल ऑनला पण 2ला मिळेल आणि ऑफला पण आपल्याला तेवढंच मिळेल सर.
म्हणजे काय होईल इथं? ड्युटी सायकल रिमेन्स 50%. सो इट इज नॉट पॉसिबल टू यूज दिस इन्स्ट्रक्शन. ओके, राईट आन्सर. म्हणजे इथं आपल्याला ड्युटी सायकल चेंज करता येणार नाही, कारण अर्लियर स्टेट जी आहे ती फक्त कॉम्प्लिमेंट होईल. मग त्याचं ड्युरेशन इथं जरी डबल केला, एक ऑल डिले अगेन एक ऑल डिले, तर काय राहणार आहे? ऑन टाइम पहिला होता त्यापेक्षा डबल राहील. त्याचबरोबर ऑफ टाइम सुद्धा पहिला होता तसंच डबल होईल. सो इट विल ऑलवेज युज्ड फॉर 50% duty cycle only, or we simply consider that it is used, or this instruction is useful for generation of square wave. Whenever we use the word square wave in that concern, duty cycle is remains 50%. And if we are talking about the rectangular wave may consist of 66% duty cycle, 30% duty cycle, or this 50%. Okay, but generally for rectangular we consider more than 50%. Okay, and when we decreases the duty cycle, or sometimes we consider like pulse or that 10%, 20%, simply we will see like this. Suppose okay, so if it is on time is this and off time is this, so on time is less 20%, suppose we consider, and off time is 80%. In that case it will be considered as a pulse if we want to generate an pulse. So from that wave we are able to generate various structures. This is regarding generation of duty cycle. So make changes or write for second part of this duty cycle of 66.67%. Okay, or write statement again one more time. Instead of writing 50%, you just write for 66.67%. Okay. Yeah. Is it visible?
Yes sir, it is visible.
So write down for 66.67%, as this question is asked in university exam more than 2 times. Both 50% and 66.67%. टार्गेटचं सांग कळालंय का? झाले मी विचारतो मी. नाव कशाला टाकले तुम्ही? केलं नाही म्हणून. केलं नाही सकाळी काल ग्रुपवर टाकले. जनरल सब्जेक्ट वाईज टाकलेत सगळेच. टार्गेट केले नाही 2 दिवस दिले म्हणून आज कालच कशाला टाकले? काही स्टुडंट म्हणलं की ज्यांनी केलं नाही त्यांना काम केलेलं नाही तेवढं हे सोपं आहे.
Completed sir.
Okay. Remaining candidates, please give response.
Sir, 1 minute, sir.
Sir 1 minute.
Okay, okay. Tomorrow we are having test on unit number 2. So be prepared at I think 10:30, na? 10:30 to 11:30. Any ruled pages you keep with you for tomorrow's lecture, that is test. And I think only few candidates have sent scan pages or scan notes and written notes written by you in your notebook or pages of unit 2. And I think more than 50% or around 50% candidates remaining to submit the unit 1 scan copy, which is written by you in your notebook, pages, whatever. So please send it. From tomorrow onwards, I will not allow for, if you have not submitted the unit 1. So please listen carefully. If unit 1 notes not submitted by you, you are not allowed to attend the lecture or my MIC lecture.
Yes, sir. Completed, sir.
Okay. So after that, we will go for normal applications. You have done it. That is addition, subtraction. No problem. We will see multiplication also. We have taken na earlier. Multiplication.
एकच एक्झाम्पल झाले सर म्हणजे प्रोग्रामचं.
Okay. So we consider the similar examples, and that too I think I have taken if a result is generated or generated result is greater than 8 bits. So lower byte is stored in accumulator and higher byte of result is stored in B register. Okay. So, and below that, whenever your result comes less than 8 bit, so it will considered as, or you seen that the result of operation is stored in accumulator and B becomes 00 as result is less than 8 bits. So lower byte is sufficient, that is accumulator is sufficient to store the result. And when we consider the result is greater than 8 bit, or if we have taken the number having the multiplication result greater than 8 bit, in that case we have seen that the lower byte is loaded or stored in accumulator and higher byte answer, whatever number is generated in hex format, it will be loaded in the B register. Okay. And if we consider the next type of multiplication, that is multiplication by using repetitive additions. So suppose if you want to multiply the two numbers 25D decimal and 10D again decimal, 25 into 10 in normal case calculator, we have seen that. So in this case, if we are considering that value 250, and if we converted that number into hex, it becomes FAH. Or you may use your calculators to convert the numbers, binary, hex, and decimal number system. All three calculations or number system conversion application is available in your calculator, that is scientific calculator 991. Okay. If you are having, please check it. And if instead of using the direct multiplication, that is MUL, if you go with another method, that is using repetitive addition. So when we want to multiply 25 with 10, you have to take the two registers. You have to take the two registers. One operand is loaded in first register. Suppose here 25 is loaded in one register, that is A, and 10 is loaded in B in normal case. So MUL AB. After that, you are able to get the result after execution of MUL AB. But if you want to get the multiplication using this method, that is repetitive addition, here you have to take one register, that is accumulator, contains one operand, that is 25. Okay. D, we consider D decimal, and another operand, instead of taking directly, we will use that operand as a counter register. So here this is acts as a counter register. So we will consider Suppose we want 25 into 10. Okay, so result becomes 250. We said D. $250, and in case of hexadecimal, whatever, suppose FAH is there. Okay, so instead of that, if we are considering 25, 25, 25, many times I have written 2, 4, 6, 8, count. I need to write one more time. Okay, 250, right. So here, if I use repetitive addition, 25 plus 25, 50, again plus 25, 75, again plus 25, in this way, if I added 25 10 times, addition of 25 10 times, I will get the result 250. I will get the result 250. Okay, so for this process, we have to write an instructions for addition of 25. How many times? 10 times. So you have to take one counter register as a 10. Counter value is 10. So in this case, you have to perform the addition 25 plus 25, 75, 100, like this. So after each addition, you have to decrement the counter by 1. Okay, so in this way, you have to write an instruction so that we will get the final answer. Okay, so here, when we consider, that is initial content of accumulator, we make it 0, clear. So before whatever contents are belonging to A, we will simply clear it. So CLR A. So we take counter register, suppose R2. You may take any register from R0 to R7 from any bank as per your selection. So here I have taken that R2 is your counter register, that is second, which is minimum. It is not mandatory to take 10 always or minimum operand. You may take this also, but that number of times the loop will be executed. So whenever we want for execution, if number of loops, that is loop execution cycle, if reduced, then your time is also saved. Okay, execution time. So here we have considered R2 as a counter, and we consider 10 value if we want to 25 into 10 multiply, and take another number, that is bigger number in accumulator, add A comma hash 25. So immediate value is added to the accumulator, and after that the important task is here. You have to decrement the counter by 1 whenever first operation is completed, that is addition. Add A comma hash 25. So decrement the counter, that is R2 is decremented. Here is also mentioned R2 decremented by 1, and it is checked whether it is 0 or not 0. If it is non-zero, go to level. So here up. So it will go to up, and then again it will go for addition. So after first addition, add A comma 25. The contents of accumulator result becomes 50. That is 25. Sorry, in first case only 25. Okay, and here value is 9. So after first iteration, A is equal to 25 and R2 becomes 9. Again it will add. So 25 plus 25, 50. And then go to this instruction, decremented by 1. So it will become 8. And it will again check whether it is 0 or non-zero. So it will continuously working in the loop until it becomes 0, that is R2 becomes 0, and addition is automatically incremented, or value is automatically incremented. At last it becomes 250 D or FAH, and whatever result is generated, if you want to load or store at any other register, it is not mandatory. So you may load by this, that is move R4 comma A. So result is copied into R4. If you want to see, we will see this in our programs also. I will simply use that only. So doing some repetitive task. Okay, so we will go with this. See, content of accumulator becomes 0. R2 is loaded with 10, that is A. Okay, so here 19 means hex value, 19H, so it becomes 25D. R2 is decremented here, that is 9, and then go to the up. So again it will add. So 32 is nothing but hex. It will equivalent to the 50D. In this way, R2 goes on decrementing and value of A goes on incrementing. So here R2 becomes 0. That's why this loop is not executed, that is not moving towards the up level. So it coming towards execution of this, that is content of A or FA, that is 250D or FAH. So after that, this result, that is content of accumulator, will be loaded in R4. So before execution of this instruction, C, content of R4 becomes 0 or equal to 0. So after execution of this instruction, it will become equivalent to the content of accumulator. So it will simply copy the content of accumulator into R4. So see here, content of AFA, content of R4 FA. Now is it clear? Repetitive addition, multiplication using repetitive addition. This program is also asked in university for 5 marks only. Hello.
Yes, sir. It is clear.
If you have any query or doubt, please ask me regarding this. Okay. So if it is clear, then we will go for next. See, just read the statement. Have you written that or not? This. Hello.
No, sir.
No, sir.
Okay. So write down first.
मोबाईलवर फोटो काढून घ्या आणि कशासाठी म्हणतात सीओ तर होतील कॉपी सीओ कॉपी होतील साठी फोटो काढून घ्या आणि म्हणजे ते 1 2 3
So you keep in mind that always whenever you want to use accumulator, then most of the time you need to clear it first, as accumulator is involved in various ALU operations. It may having some contents, and that to the operation like arithmetic operations or logical operation. That time it may happen that it will be added with the previous content, or it may be subtracted from the previous content if you are not loading the content in accumulator before operation, that is move a comma hash 0 to h or move a comma hash 20h, like that. Okay, if you are not performing data transfer instruction before the actual arithmetic instruction, in that case there may be possibility of malfunctioning or misleading the result. For that purpose, you have to make sure that your accumulator contents are as per your requirement. So our requirement in case of this operation, that is addition, 25 and 10 multiplication, sorry. So in this case, any one operand should be present or transferred loaded in accumulator, and other operand as per your method of writing the code. Here we are doing multiplication, but in different manner. If you use directly multiplication, then simply load accumulator with first operand, load B register with second operand, and directly use MUL AB. Complete, finish. But if you are thinking in other manner or other method, in that case you have to make sure that before using accumulator for each and every operation, before using accumulator, if you have done or written the instruction in data transfer mode, that is move a comma, that is the contents belongs to accumulator as per your requirement, then you are simply or you are eligible to write any ALU instruction, that is addition, subtraction, and or XOR whatever. But if you didn't write anything related to the content of accumulator, or you didn't know anything related to the content of accumulator, in that case you may mislead the results. Okay, is it clear? Have you written?
Yes, sir.
Yes, sir.
So after that you just take this statement only. Another example, you go with this. We will see if the result is greater than 8 bit, what should be done. After these programs, we will move towards the delay generation, that is timer, as per the requirement, 1 millisecond, 10 millisecond, 1 second, like this. Okay. These are the some general programs. Okay. Have you written the statement?
Yes, sir.
Okay. So see, in this case, we have to multiply two hex values, EC and 25. Both are in hex format. EC multiplied with 25, and the result is 221CH. Okay, so it is mentioned only. So in this case, we are knowing or thinking that if result is greater than 8 bit, what will happen? Okay, so in this case, we have to identify the carry, whether carry is generated or not. So when carry is generated, in that case, you have to analyze the carry generated. Okay, and for the next operation again, if it is required, then we have to analyze the carry. Okay, so here not the case of directly multiplication, that is mul AB, and you have to analyze the C status. Here we are using repetitive addition. That's why, similar to earlier case, we are going with the one operand 25 is loaded in suppose R5. So move R5 comma hash 25H, and another operand for the sake of simplicity or for addition, one operand is always accumulator. So we are going with the accumulator, that is add C comma A hash ECH. So content EC will be added in accumulator. Before that, you have to clear the accumulator as well as carry. So initial status we don't know for both the two, that is one is register accumulator, another one is flag, carry flag. So initial state you have to clear these two, carry and accumulator. So if we want to analyze the status of carry, then you go for the addition through carry or addition with carry. So add C A comma EC. So now we are adding EC with the accumulator. How many times? Here, if you are seeing that the counter is R5, so counter is always associated with this instruction, DJNZ. So keep in mind, whenever we want to use a register with some number as a counter, 10 times, 20 times, 5 times, whatever, increment, decrement. So when we are discussing the counter, so it will be associated with this instruction, DJNZ. So counter and DJNZ are merged together. Okay, so it is necessary to use DJNZ if you want to decrement from maximum number to 00 for number of operations. Okay, so here R5 becomes counter register and here it is decremented, and check the status every time after every decrement. Okay, so R5 is counter and initially you have to clear both C and A. If you return after org, no problem, CLRC, CLRA, and then if you have written, you take your choice, use your choice. Okay, so first case, accumulator is 0, add C, A comma ECH. So content of accumulator becomes EC if carry is generated or not. How it is tested? Like this, JNC, jump on not carry. So jump on not carry, JNC, you keep in mind. All right, JNC. Okay, so whenever carry is not generated, it will simply going or moving towards the label. Label is here, here हे एक लेबल दिले आपण, JNC here. जेव्हा जेव्हा कॅरी 0 असेल म्हणजे जम्प ऑन नॉट कॅरी, म्हणजेच काय, कॅरी नसेल तर जम्प करायचंय कुठं, हिअरला, मग तो इथं येईल. ओके, समजा फर्स्ट ऍडिशन झाली, कॅरी जनरेट झाला नाहीये असं कन्सिडर करू, पण इसी एफ पेक्षा जास्त नाहीये, कॅरी जनरेट झाला नाही, मग कुठे जाईल तो, हिअर या लेबलला. लेबल कुठे आहे, इथं. इथं काय एक्झिक्यूट करायचं आहे, DJNZ. कोणाला डिक्रिमेंट करायचं आहे, R5 ला. जम्प कुठं करायचं आहे, लेबलवरती. काय लेबल आहे इथं, अप. आणि कधी जम्प करायचं आहे, नॉन झिरो असेल तर कोण, R5. म्हणजेच काय, जेव्हा R5 एकने डिक्रिमेंट केला आणि जर नॉन झिरो असेल तर कुठे जम्प करायचा आहे, अपला, मग तो अपला जाईल इथं. परत एकदा काय करेल, ऍडिशन, म्हणजे इथला R5 जो डिक्रिमेंट केला तो 25H परत सबस्ट्रॅक्ट होईल एकनी 24H. सो इन दिस वे इट विल गोज ऑन डिक्रिमेंटिंग. ओके, सो अगेन इट विल गो टू द अप. सो ऍड C A कॉमा EC, परत तेच आपण जे अगोदर पाहिलं 25 आणि 10 चं, 25 add 25 plus 25 plus 25. So instead of using this, here we consider the carry also. Okay, for checking whether result is greater than 8 bit or not. Okay, so we will go second operation. So EC plus EC, whatever result is there, and in that case if carry is generated, that is when your result is greater than 8 bit and carry is generated, in that case it will not go to directly to the here label. So it will go to the next instruction. Jump is not allowed when carry is generated. So it will go to the next instruction. Next instruction is increment R3. Here R3 is also taken for checking the how many times carry is generated. Okay, so R3, initially we have to taken the value of R3 is 0 0. So after generation of first carry, it will incremented by 1, that is it becomes 1, and again it will go to for decrement. Okay, so again decrement the R5, that is second operation is there, 23H is there. Again it is not equal to 0, so it will jump to the up, and again this instruction is executed, add C, again checking the carry. So in this way, when the number of times carry generated at that time interval or in that durations, R3 is incremented by 1 each time whenever carry is generated. If not, then R3 will not be incremented. So consider that R3 is incremented only if when carry is generated for the addition operation, and when carry is not generated, in that case it will simply skip the R3 increment operation, and this operation is executed each and every time, decrement and jump, decrement and jump, if not 0. And when it becomes 0, it will reduces from 25 to 00H. In that case, it will not go to the up. It will simply execute the next instruction in sequence, that is move R6 comma A. So whatever contents belongs to A, that is lower byte result, will be copied to R6, and higher byte result will be this R3. So final result is R3 R6. Final result is R3 R6. So like this. So whatever the operations are there, so here R3 and R6. Okay. So these two are the, sorry, here we consider as LSB 8 bits. Here MSB 8 bits. Okay, so this belongs to accumulator and this belongs to R3 as I have mentioned already. R3 चे कंटेंट कॅरी जे इन्क्रीमेंट होत राहील ते इथं असते म्हणजे MSB ला, आणि accumulatorचे कंटेंट जे आहेत ते लोअर बाईटला असते. ओके, क्लिअर आहे. फायनल रिझल्ट R3 आणि R6. एनी हाऊ तुमचा accumulator फक्त 8 बिट साठीच असेल. 8 bit operation is loaded or stored. Beyond that, it will not load or stored. So simply it will increment the higher bit and again continues. Okay. जसं की 99 plus 1 काय येतं 100. So earlier 99 becomes 00 and MSB bit becomes 1. Again same 999. So all three nines become 0 and 1 is added or shifted in forward direction. Forward direction in the sense of increasing ones, tens, hundreds, thousands, 10,000s, lakhs, 10 lakhs and crores. जशी पोझिशन आपली वाढत जाते राईट हँड साइड कडून लेफ्ट हँड साइड कडे, तसंच नंबरचं पण होत जाईल. D0, D1, D2, D3 असं प्रत्येक ह्याला काय होईल, ते बीट पोझिशन्स इन्क्रीमेंट होत जाणार. लाईक सपोज इफ वी कन्सिडर D0, D1, D2, D3 एवढंच कन्सिडर करूया. इथं 0 असेल आणि इकडे सगळे 0च आहेत कन्सिडर करा. जेव्हा हा 1 बनतो प्लस 1 होईल याच्यामध्ये, तर हा 0 बनेल आणि हा 1 होईल. परत हे दोन्ही ज्यावेळेस 1 1 असतील नेक्स्ट ऑपरेशन, परत काय होईल, हे परत 0 0 बनतील आणि इकडे 1 होईल. असं काय होईल, कंटिन्युअस ऑपरेशन तुमचं शिफ्ट होत जातील. आर यू गेटिंग? हॅलो.
येस सर.
Okay, so write down for this as, if we want to multiply the two numbers hex values and that too we are considering result is greater than 8 bit, so we have to use the carry flag, or you have to analyze the status of carry flag for each operation. That's why we are considering add C. In earlier case we don't care the status of carry flag because we are considering that result is below 8 bit, that is not exceeds the FF पेक्षा जास्त आहे का रिझल्ट नाहीये, म्हणून इथं कॅरीची कंडिशन अनालाइज करायची गरज नाहीये. बट व्हेन द कंडिशन इज लाईक दिस, इफ result is greater than 8 bit, in that case you have to analyze the carry flag. So for that purpose we are using add C instead of using add only. Okay, clear hai add C, why it is used? Okay, right.
एक्सक्यूज मी सर.
Yes.
सर एक कन्फ्युजन आहे.
हा बोला ना.
सर आपण R5 ला 25 हेक्स दिलंय, हा, आणि इथे खाली अक्युमुलेटर क्लिअर करून घेतलं. जेव्हा आपण ऍड करतो तेव्हा EC A मध्ये जाणार, आणि EC A मध्ये गेलं की तेव्हा काही कॅरी नाहीये म्हणून ते डायरेक्टली हिअरला येऊन आपले DJNZ परफॉर्म होणार आणि डिक्रीमेंट R5 होणार, आणि R5 24 झालं. मग 24 नंतर ना सर ते एम ते कळत नाहीये.
बरं, ठीक आहे. We will simply go with this program also in A. तुम्हाला हे स्टेप बाय स्टेप झाल्यानंतर कळेल. Sorry, we need to stop the debug. Test your program. Okay, program is Tested here, I will simply save, debug, 0 errors, go for execution. ओके, ते प्रोसेस मोठी आहे तरी बघू आपण. फर्स्ट R300 घेतला, आता R5 काय झालंय 25. ओके, आता इथं हेक्स म्हटलं होतं आणि ह्या सगळ्या हेक्स व्हॅल्यू आहे, त्यामुळे तिथं काय मेन्शन होत नाही. डिफॉल्ट स्टेटस काय इथं हेक्स. क्लिअर ए होताच तरी क्लिअर केलाय. क्लिअर सी, कॅरी दिसतंय इथं, इथं आहे सगळ्या शेवटी CY. ओके, पुढचीच कंडिशन घेऊ. आता फर्स्ट ऑपरेशन हे एक्झिक्यूट व्हायचं आहे, हे एक्झिक्यूट होणार आहे आता येलो मार्किंग, आणि जी ग्रीन टॅब आलेला आहे तेवढे एक्झिक्यूट झालेत. ह्याने प्रोग्राम काउंटर आहे तुमचा हा 6 इथं पॉईंट केला आहे त्याने. आता ती एक्झिक्यूट करायची. ओके, तर ती एक्झिक्यूट करताना बघा, वी विल एक्झिक्यूट. सो कंटेंट ऑफ अक्युमुलेटर EC, कारण अगोदर 0 होता आणि ती EC ऍड झाली. 0 + EC काय झालं EC. आता इथं काय पॅरिटी फ्लॅग सेट झाला नंबर ऑफ वन्सच्या पोझिशननुसार, आणि कॅरी फ्लॅग बघा सेट आहे का इथं नाहीये. ओके, सो इट बिकम्स रिमेन्स 0 रिसेट स्टेट. आता पॉईंट कुठे केलाय JNC, कॅरी फ्लॅग चेक करायचा आहे. त्यांनी चेक करून हिअरला जम्प करायचं की नाही हे डिसाईड करणार आहे. आता ते आपण एक्झिक्यूट करू. कॅरी तर जनरेट झालेला नाहीये, मग त्यांनी कुठे जम्प करायला पाहिजे हिअरला, लाईक दिस. गेलं का हिअरला, त्यांनी R3 इन्क्रीमेंट केलं का नाही, त्यांनी काय केलं कॅरी 0
डायरेक्टली
असल्यामुळे
हिअरला आलं.
हिअरला गेला. जर कॅरी सेट असता तर तो हिअरला गेला नसता, त्यांनी नेक्स्ट ऑपरेशन इथं जे काय असेल ते एक्झिक्यूट केलं असतं. आता या केसमध्ये आपलं इन्क्रीमेंट R3 नाही. ओके, नाही गेला, त्यांनी हिअरला गेला. तर हिअरला गेल्यानंतर त्याला ऑपरेशन काय करायचं डिक्रीमेंट, आणि मग नॉन 0 असेल तर जम्प कुठे अपला, ते बघूया आपण. त्यांनी डिक्रीमेंट केला 24 झाला. 24 झाल्यानंतर नॉन 0 आहे का, हो नॉन 0 आहे. कोण R5, मग कुठं जायला पाहिजे अपला, त्याने गेला अपला. आता आपला गेलाय, आता ते परत एकदा एक्झिक्यूट करायचं. आता ए चे स्टेटस काय EC, त्यावेळेस हे किती झाला 24, आणि परत एक्झिक्यूट करू आपण. ऍड केल्यानंतर काय झालं ते D8, ऍडिशन काय झाली D8, आणि कॅरी पण ऑक्झिलरी कॅरी पण सेट झालाय, कॅरी पण सेट झालाय. क्लिअर आहे बघा.
हो सर.
हा, आता याच्यानंतर काय करायला पाहिजे त्यांनी, कॅरी जर सेट झाला असेल तर डायरेक्ट हिअरला जाईल का, नाही, त्याने R3 इन्क्रीमेंट करायला पाहिजे. केला का R3 इन्क्रीमेंट, सॉरी पॉईंट केलाय, आता इन्क्रीमेंट करेल. झाला का इन्क्रीमेंट, झाला. मग R3 इन्क्रीमेंट झाल्यावरती परत तो डायरेक्ट अपला नाही जाणार, नेक्स्ट इन्स्ट्रक्शन. नेक्स्ट काय हिअर, आता हिअर हे लेबल आहे त्यामुळे इन्स्ट्रक्शन इथं ऍक्च्युअली डिजेंजेड तेच ऑपरेशन परफॉर्म करेल. परत एकदा डिक्रीमेंट केला 24 23 झाला, अपला गेला, परत चेक केला, कॅरी परत जनरेट झाला. कॅरी जसं जसं जनरेट होतोय तसं तसं ते इन्क्रीमेंट होत राहते. We will go for all the operations. Have you understood?
येस सर. म्हणजे आधीच्या ऑपरेशन मध्ये जे अक्युमुलेटर मध्ये व्हॅल्यू आहे ती आणि EC ह्या दोन्हीचं ऍडिशन होणार आहे.
ऍडिशन होणार, आणि परत कॅरी चेक करणार. जर कॅरी सेट झाला परत R3 इन्क्रीमेंट. कॅरी काय इथं प्लस होत नाही, हा फक्त सेट किंवा रिसेट हेच होत राहणार. इथं कॅरी कॅरी काय तिथं 1 परत 2 3 असं नाही होणार. कॅरी काय होणार एक तर सेट किंवा क्लिअर. ते बघा 20 पर्यंत पोहोचलो आपण R3 ला. आता R5 बघा 1 राहिलंय, आता हा 22 झालाय. लास्ट फ्यू ऑपरेशन्स हा 0 झाला. आता हा 0 झाल्यामुळे त्यांनी परत अपला गेलाय का, नाही, तो कुठे आला खाली मूव्ह R6 ला. क्लिअर आहे.
येस सर.
2 आणि इथं काय सपोज 3 संपलं, एरर आहे. ओके, सो इन दिस वे R6 चे कंटेंट 3D आणि 2 to 3D हे तुमचं फायनल आन्सर असेल. 2 to 3D कदाचित मी वेगळं दाखवलंय का, 2 to 3D आहे, सॉरी 3D. आता क्लिअर आहे हाऊ इट वर्क्स.
येस सर, आता क्लिअर आहे.
रिमेनिंग कॅन्डिडेट्स, हे तुमचा ए म्हणजे काय लोअर बाईट आहे, आणि R3 म्हणजे काय हायर बाईट आहे, जसं की आपण इथं मेन्शन केलं होतं. जिथं काय आन्सर आले 2 2 आणि 3 डी आणि कंबाईन काय तुमचं फॉर्मॅट काय हेक्स. दिस इज युअर ऍक्च्युअल नंबर रिझल्ट. ऑल ऑफ यू क्लिअर दिस? हॅलो.
Yes, sir.
येस सर क्लिअर.
मग आता रिपीटिव्ह ॲडिशन म्हणजे मल्टिप्लिकेशन युझिंग रिपीटिव्ह ॲडिशन फॉर द रिझल्ट less than 8 bit or within 8 bit, we simply say that within 8 bit, and this is the operation for result greater than 8 bit. Okay, so we will see this is last from this side. Let us see the statement. Write ALP for condition 1. Keep monitoring of P1.0. एकच बिट मॉनिटर करायचं आपल्याला कुठलं P0.1 पोर्ट 0 मधला बीट 1. ओके, अंटिल कधीपर्यंत मॉनिटर करायचं आहे? अंटिल इट बिकम्स हाय. जोपर्यंत ते हाय होत नाही तोपर्यंत आपल्याला मॉनिटर करायचंय. म्हणजे चेक कोणाला करायचं आपल्याला? P0.1 ला कंटिन्युअस चेकिंग पाहिजे. ओके, ही झालं पहिली इन्फॉर्मेशन आपल्याला मिळालेली गिव्हन इनपुट्स. ओके, किंवा गिव्हन डेटा. सेकंड केस काय म्हटले त्यांनी? त्याला आपण केस 1 म्हणू किंवा केस ए. केस 2, व्हेन P0.1 बिकम्स हाय, म्हणजे इनिशियली काय असायला पाहिजे? ते लो. जेव्हा हे आपण कंडिशन टाकतोय की व्हेन P0.1 बिकम्स हाय, याचाच अर्थ ते इनिशियली काय असणार आहे? लो असायला पाहिजे. ओके, आणि जेव्हा हे हाय बनते तेव्हा काय करायचंय? रीड डेटा फ्रॉम P1. जेव्हा P0.1 हाय बनेल तेव्हा डेटा कोणाकडून घ्यायचा आहे? कंट्रोलरनी रीड करायचा आहे P1 कडून. ओके, दिस इज युअर सेकंड केस. आता थर्ड केस. आता ही एक्झिक्युशन झालं की थर्ड काय करायचंय? सेंड ए लो टू हाय पल्स. एक पल्स द्यायची आपल्याला जी इनिशियली लो असेल, परत हाय करायची. कुठल्या पिनवरती द्यायची? P0.2 त्याच्या पुढच्या पिनला. टू इनिशिएट दॅट डेटा हॅज बीन रीड. ते आपण डेटा रीड केलाय असं दाखवण्यासाठी एक सिग्नल जनरेट करायचा आहे, रिस्पॉन्स थोडक्यात जनरेट करायचा आहे की आम्ही तो रीड केलाय. म्हणजे काही वेळासाठी ऑन करायचे आणि परत ऑफ करायचे. लो टू हाय पल्स एक द्यायची आपल्याला.